recording. If you'll stand a little bit closer to the desk and introduce it, please.
All right, so my name is James Kaiser. Thank you all for coming to this special session of the Interdisciplinary Distinguished Speaker Series. This is the first one we've had this semester. I'm the technical director for the Laboratory for Analytic Sciences, and we're sort of helping to sponsor Hamid Krim's IDSS talk here. So I sort of got the Liquid Narrative Group, as represented by Markus Eger, to come in and give a little talk on part of some of the research that he and his team are doing under the direction of Professor Michael Young in what we're calling narrative processing in the LAS. This is one of 8 or so interesting research themes that we have working, that we're studying here with our collaborators at the university and local industry. And in addition to narrative processing, we're investigating things like analytic workflow and cognitive processing, things we call future states. There's some things about infrastructure, some very interesting stuff on instrumentation, which we'll have another special IDSS presentation on in a couple of weeks. But if you're interested in more information specifically about these research themes, you can take a look at las-ncsu.org and look under the research categories. Sometime today we'll have some executive summaries for each of these things up. What Markus will talk about today is a mechanism by which we're trying to provide data to our different collaborators, our different academic and industry collaborators, and that's this collection of game log data and the kinds of analyses that you can do with game log as opposed to just recreating the game. There's a lot of neat stuff that you can do with it, and these are the kinds of things we're studying at the LAS. So without further ado, Markus is a first-year graduate student, so he's brand spanking new for the most part. He's working with Michael Young and Jeff Ligon and Dave Roberts and the Liquid Narrative Group. He's got several of, I mean, you guys all know who he is, and you guys are probably part of it too. And without further ado, Markus.
Okay, thank you for the nice introduction. So I'm Markus Eger, and I will talk about Defense of the Ancients, replays, and log files. And first, I will introduce the game, which gives a bit of a context of the kinds of data we have and what you can expect, and maybe give an idea what the data can be used for. Then I will explain how the game actually stores this data in its replays. And after that, I will explain how we extract the data into log files and what those log files look like at the moment. And, well, there's time for questions at the end, but feel free to interrupt me at any time if anything is unclear. In the beginning, like a short overview about the game. We call it DotA 2, but it's actually Defense of the Ancients 2. It's a team game, so there are matches played between 2 teams of 5 players each, and the goal of each team is to destroy the enemy team's main building, which is called the Ancient. There are 3 paths between the 2 lanes, between the 2 bases, which are called lanes. I will have a picture of the map shortly, so you can see that more clearly. And each lane has several towers for defense, so these towers attack enemy units that come within range. To help the teams, there are weak computer-controlled units that spawn in regular intervals in each base and move through the lanes to the enemy base and attack any enemy units they encounter. And to help these computer-controlled units, which are quite weak, each player chooses one from 105 heroes. Each hero has its own abilities, strengths, and weaknesses, and its own role in the team, and tries to attack the enemy base as well. In the beginning of the game, the heroes are weak, but over the course of one match, they gain experience, gain levels, they can learn new abilities, and become a lot stronger. So here we have a map of the game. Maybe use red. And here are the bases of the 2 teams, the main buildings that each team tries to destroy. So one team starts out here and tries to work its way towards this main building, this Ancient, and the other team starts there and works this way. But we have lanes on top and on bottom, and one diagonally in the middle, where towers are positioned. I will just draw the towers for one lane. So these towers are controlled by the team in the top right corner. Then we have the computer-controlled units that spawn here, move along the lane, and since the other team also has computer-controlled units that spawn here and move in the other direction, at some point they will meet and fight each other. And the players control heroes that spawn here, and they can just move. Thank you. So the players have their heroes, and they can move and help their computer-controlled units. Perfect. Thank you so much. That can help their computer-controlled units to...
Can you turn those lights back on? I'll turn off the front wash ones. Sorry about that.
I said perfect. Cannot improve on that.
I need those lights on for the video. Thank you.
Okay. Anyway, the heroes help their computer-controlled units trying to work their way towards the enemy base. And to destroy this tower, this other tower has to be destroyed first. And likewise, for this tower to be destroyed, this tower and this tower has to be destroyed. And for the ancient to be destroyed, all the towers in one of the 3 lanes has to be destroyed as well. And the game is over when one of the ancients is dead. So the player's influence to the game comes through the heroes. So each player chooses one hero, as I said before, and each hero can learn up to 4, usually up to 4 abilities that are specific to that hero. I will have an example for a hero later. And when they are near an enemy creep or hero death, they will gain some experience, and at certain experience thresholds, they will gain a level. And whenever they gain a level, they can learn either a new ability of their 4 hero-specific abilities, or improve one that they already have learned. When they actually kill a creep or enemy hero or an enemy building, they gain some money. And with that money, they can buy items that improve the hero's abilities, or life, or damage, or give other certain bonuses. And when a hero dies, he loses some of the money he has, and stays dead for a certain amount of time, after which he just respawns. And that time increases in length over the duration of the game. Each ability also has a cooldown, so if you have your super fireball, you cannot just cast it all the time. You have to wait like 15 seconds between using it. And they cost mana, which is like a resource that each hero has that regenerates slowly over time. As an example hero, I have chosen Crystal Maiden because she is like a typical spellcaster in the game. She has abilities that slow or freeze enemy heroes. She has very low health and low attack damage, so she's more useful for support roles. Her first ability just targets some area on the map close to her and releases a Nova of Frost. And all enemy units in that area take damage and are slowed. And if the ability is improved, which can be seen here by those yellow dots, so this ability is on level 4, then it does more damage and slows the enemies for more time. And in the game, that looks like this. So here we have Crystal Maiden, and she targets some area. And when she actually casts the ability, it looks like this. The units that have this health bars above them are the creeps. This unit is the hero. She has a bigger health bar above her, and you can also see her mana pool. And the ones that have green health bars are on our own team. The ones that have red health bars are on the enemy team. And you can see those red creeps here have some ice effect on them, so they are slowed. Her second ability just targets a single unit and freezes it in place. So the targeted unit cannot move, and it takes some damage over time, but it can still attack. That looks like this. So we have Crystal Maiden again, and now we have an enemy hero, and he has this ice effect around him. So that means he's frozen in place and cannot move. Her third ability is not activatable at all. It's just a passive mana bonus to all allied heroes that are on the map. She herself gets twice the bonus, but of course when she's dead, there's no bonus for anyone. And finally, she has an ability called Freezing Field, which she can cast over a period of time. It lasts like 5 seconds. And while she does that, she cannot move, attack, or anything else. She has to like channel the spell. And in that duration, there are ice shards falling down all around her and damaging all enemy units that are somewhere around her. But the enemy can interrupt this channeling by stunning her, by silencing her, by doing various things to her. And
when she freezes an enemy, go back a couple slides, when she freezes an enemy, is it one of these things where, so this guy here, this enemy is frozen, can he be frozen to different degrees?
No. So
it's either frozen 100% or
no,
not
in
at
that
all.
case it's just frozen means he cannot move. And he can still do everything else, but she just cannot move.
When that avatar or character is frozen, can it be targeted by anyone else?
Yes. So, yeah. This is a scenario where we only have Crystal Maiden and she just freezes a guy, which I created just to show off the ability. But yes, in actual gameplay it will often happen that she targets one guy and all the team will focus on that guy. Okay, so channeling. She's just standing there, focusing on her spell, and ice shards are falling down. That was a bit tricky to screenshot, because you will have to imagine there are ice shards falling down. And you can see here the channeling duration, which counts down, and as long as that happens and she's not interrupted by anyone, she just keeps on channeling that spell. So those were 4 abilities, and they were all different in kind. There are various other kinds of abilities, like one we call skill shot, which is just a hero shoots a projectile in some direction, and whatever that projectile hits is the target of the ability. So it's called skill shot because you need some play skill to actually hit the right target. Then there are auras, similar to what Crystal Maiden does, where she gives mana regeneration bonus to all the heroes. Other heroes have auras that only work in a certain range around them. Then there are blinks, which are just instantaneous changes of location. So we have heroes that can stand somewhere, then activate an ability, and suddenly appear somewhere else. Another common type of ability are triggers, or procs, which usually occur when a hero attacks someone else. Like, he has a 20% chance to do twice the damage, or he has 10% chance to stun the enemy, or something like that. Some heroes can also summon allied units, like wolves or weaker copies of heroes, or they can take control of some creep or whatever. And why I'm talking about this is each of these ability types is represented differently in the replay. So to actually extract this data from the replay, one has to implement basically each ability by hand individually, because they're all kind of similar, but all very different in the end.
And that's at the level of programming the game, or is that something else about using the applications in the game to get these abilities?
I will come to that shortly.
Okay, because I was going to ask the other thing is that can I put the 7th bullet up there that says invisibility? How would I program that? I mean, that's a future capability, a future ability for your characters. I'm interested in knowing how that can possibly be done.
Sorry, can you repeat the question?
Can I add a 7th ability? Let's call it invisibility.
Okay, that's an actual ability in the game.
Oh, okay. But it's not on your list.
It's not on my list, you're right. So that's just examples. There are others that I probably did not think of.
An 8th ability, whatever it could be, an 8th bullet on your list.
Super arrogance.
Yeah.
I wouldn't know anything about that. Is Death of the Defense of the Ancients, is that a sufficiently open source kind of game that you can add that as an ability?
No.
Not at all.
Not at all.
You have to write them and say, would you pretty please do something for me?
Yes.
Like this. All right.
So I've heard back when the game was smaller and the community was smaller, that would actually work. So the developers would actually take suggestions from the players. But the game has grown since, and I think it's harder to get through. Maybe if you have like a really awesome idea, they might do it. But yeah.
Okay.
But no, we cannot add anything to the game. It's hard enough to get the data we have in the game out of it again. So, yeah. So, how does the game generally work? In the beginning of the game, you have these 5 players on each team, and they distribute over the lanes. Like usually, or often it's 2 players on the top lane, 2 players on the bottom lane, and 1 player in the mid lane. And they just stay in that lane, kill some creeps, try to gain experience, gain levels, get stronger. Sometimes there are smaller skirmishes, like one hero gets too close to the enemy heroes and they attack him. Often no one dies, sometimes they do. But what can happen is a player leaves his lane to ambush another lane. Like, if you don't see players coming from other lanes because visibility, because they're invisible, because they are behind a tree or something, they can actually like, oh, there's another guy suddenly appearing out of nowhere, and they work together to kill an enemy. Later on in the game, the teams usually gather, and you have really 5 players on each in one region, and the other 5 players in the same region or close region, and then there are team fights happening a lot. And during these team fights, each player has to decide, is my team attacking? Because, so in professional games, they usually have like some sort of speech communication. When you just play the game casually, that often doesn't happen. And sometimes people don't even tell you what they're going to do in any form. They just go in towards the enemy players, and each player has to decide, is my team capable of winning this team fight? Should I follow through with what my ally is doing? Or should I just hang back? Should I wait? Should I retreat? And all these things. Players don't have complete information because enemies can be hidden behind trees, because they don't know what their allies want to do. But they have to decide quickly. So it's not like they can sit there and think for half an hour, should I go through? Do we have a chance to win this fight? They really have to basically decide instantaneously.
I have a question.
Sure.
How is the collaborative behavior amongst the team identified? How does that manifest? Is there a back channel of audio communication? Is there a little text going on?
Theoretically, there is. Most people don't use it in casual games. In professional games, all the teams always talk to each other.
And in the course of doing the game logging, when we're talking about the game logs here, is that information captured and stored someplace?
I will come to that later.
Okay.
But there are things like, in the game, even if you don't talk to each other, you can like alt-click somewhere, and exclamation mark will show up at that point in the map. So you can signal your allies, hey, I want to go there, by clicking there and like showing a beacon of targets or whatever. And well, you can actually, there's a sophisticated notification system. You can tell them, oh, my ability is now ready for use, or I don't have enough mana for that ability, or I don't know where this enemy guy is going, and all kinds of other things. Like, we should attack this tower now, we should defend here now. All these things exist. They are just sometimes used, sometimes they're not, depending on how comfortable the players are with those things.
If you're playing as a team,
Yes.
and one of the team members runs out of money, can he borrow money from another team member?
No, he cannot. So you play as a team, but everyone kind of has to work for their own goals as well, like money. But you also have to know some heroes don't need money. They can buy items, but they don't really benefit from those items as much as another teammate would. And since when you kill an enemy hero, actually the guy who kills him gets the money, you have to be careful that if you're a support hero who doesn't need the money, that you don't accidentally kill someone when your ally is nearby and could have done the killing instead of you and would have gotten the money. So that's another level of teamwork that's there. That should be there, but that's kind of hard to achieve.
So the character kills another character, and a third player gets the benefit from that?
No, they don't. That's exactly what I was trying to convey. Like, you have 2 heroes from your team and 1 hero from the enemy team. And whoever kills that enemy hero gains the money. So say one of your heroes is a support hero who does not need money, and the other one is a carry. Like, that means he will carry the game to victory in the late game, and he needs a lot of money to do that. So it would be wrong, strategy-wise, for the support hero to kill the enemy. But maybe he will do that because he just uses some ability to kill him, even though the carry could have done the same, but was just a millisecond slower. So in professional games, people will know, I don't need the kill, I will wait and not do that. But when you play casually, most people just try to kill as much as possible, and even if it's wrong. So I believe that's a great opportunity for cognitive processing to see how the players come to these conclusions. Yeah.
Come in.
I think that's our lab.
That's him.
So in the next part, I want to talk about, so now I've talked about how the game works. The next part is how is that actually stored by the developers. Like, you can download a replay. After you play the game, you can download the replay. You can watch your game again. You can watch that from a free camera, like you can move wherever you want. You can focus on the view of a particular player. So you see exactly what they saw. You even saw where they moved their mouse, what they did during the game. Or you can have the game create a highlight reel, basically, for you, which is not that good, I have to say. But it tries to move the camera wherever most action is happening, basically. So in this replay, it basically consists of 3 parts. One part is stores for each object, like heroes, creeps, buildings, abilities, everything that occurs as a game object in the engine. It stores all the attributes 30 times per second, and that's called a tick. Notably, that's just like attribute values. That's not changes in attribute values. You have to calculate that yourself. Then we have a combat log, which is actually used for the player to display them what happened to their character. I will have a picture of that combat log later. It shows damage events, it shows heal events, it shows when someone gets some bonus from some other player or is negatively affected by some enemy player. And then there are user messages, which are used by the engine to display things to the user, like particle effects, like attack animations, like chat messages, hero death announcements, things like that.
Can you say another thing, something else about this the first bullet, per object record object?
Yes.
You said that's something that the analyst or the person looking at the replay would have to calculate? What do you mean by that?
No. So the information is stored per tick. So in each tick, you know where each hero is. But you don't have any information about where a hero moves. You can just calculate that by looking at the positions of the hero over time. And I will show later how I do that.
Okay.
So that's how the game stores the data.
So it's just a sequence of X, Y
yes,
coordinates.
basically
So
it's
here
just,
to here to here
yes.
to here. At this time, at some other time, and that the delta t's between them are just ticks.
Yeah, that's 1/30 of a second. Yes, so I actually do a lot of this post-processing already because that's not useful information for our task. Like, we don't want to know where each hero was. We really want to know what they were doing. Same for the abilities. For the abilities, this stores the current cooldown. We don't want to know how long the ability needs to be reactivated. We want to know when it was activated, which can be done by using that cooldown information.
And the per object here, the hero, creep, building, etc., those are all labels. So there's a hero 17 and a hero 18 and a hero 19, or just
yes.
sort of labels like that, or names?
Basically, they are names, yes.
Okay.
So one thing is, in most games, there can only be one hero of each type. So when someone chooses Crystal Maiden, no one else can. Which helps me a lot because, as we will see, the combat log does not really refer to these objects. It just refers to names. And even in this per object tracking, it's a lot easier if you just track by name. Okay, anything else? Okay.
I have a question.
Yeah, sure.
So this chat messages is within the team member, or if like any particular person of team player, I mean, a particular team can exchange an emotion with the opponent team, like demotivating, like he killed us.
Yes, both of those are available.
Okay, great.
So whatever players say, like when you actually type text, they can either talk to their allies only, or they can talk to everyone.
Within the team members, that is not exposed to the opponent.
They're both. They're both within the team members and to everyone.
To everyone. Okay.
Yeah. So yes, you can see that too. So from personal experience, I have to say it does not happen that often. Like most of the time, what you say to everyone is good luck, have fun, and at the end of the game you say good game, and that's most what you say. some games, and I would say that the more interesting ones are those where you actually talk to the enemy team.
Okay.
But
and
yeah.
inside the game also there may be some sort of somebody, maybe the team leader, and he's leading the team and he's exchanging messages with his team member
Yes, so officially there's no team leader, but there can be some player who decides, okay, I know a lot more about this game than you do, I will tell you what to do. And that's actually helpful for players, if they can follow instructions. Okay, so the combat log. Oh, sorry.
Is it the actions of the players?
The combat log?
Yeah.
Yes and no.
Are the clicks recorded?
The clicks are recorded. They are not in the combat log. So the combat log is really this textual representation. It really just says range creep hits some hero with damage.
Not there, where are they? Because you gave us 3 different options on
the clicks are in the user messages.
Clicks are user messages?
Yes, because so the way this works, the replay is really just for displaying the game to someone who wants to watch it. It's not like information for the game engine to actually replay the game, to recalculate everything. It's really just visual information. And the clicks are something that are just displayed on screen for someone who is watching the replay. So they just see the cursor moving.
So they're shown as things to display, but
yeah.
They are not, are they ever logged into the dem file?
Into the, yes.
EM.
Yes, they are logged into that file, but as display events. Yeah. So I will tell you now, there is a problem with the click messages. We know that they are in there, but we cannot access them at the moment. We know that they have to be in there because they can be seen when you watch the replay in the game.
So the structure of the EM file is not public?
No. Yeah, I will come to that later. Remind me again if I miss anything that you want to know. Sure. Yeah?
Can somebody access this file during the game?
No. Actually, after the game is finished, you have to wait like 3 or 5 minutes until it's available.
Is this a text file? How is
no,
it written?
it's binary data.
It's binary.
And yes, it's binary data. It's closed source. That's one of the challenges here. Any other questions about this? Okay, I will proceed with the combat log. So, I don't know, I hope you can read this. First line says, Tinker receives rearm buff from Tinker. So that basically says, Tinker is a hero, rearm is one of his abilities, and buff means he gains a bonus from it. So he just cast this ability on himself. The next line says, range creep hits Tinker for 10 damage. And it says how much health he had before and how much health he has after this damage event. Note, it says range creep. There can be many range creeps on the map. We don't know which one that was. And that's a real problem. So we only know it was some range creep. It's probably the one that's closest to Tinker, but it might be that there are multiple there. And then we don't know which one that is. Again, this is only for the player to see. The player does not really care which creep it is, because they see the creeps performing the attack animations. We have that information. When does the creep perform its attack animation? And they see my hero lost life, but they really don't care from which opponent that damage came.
In the game engine, all these entities, especially the autonomous ones like the creeps, are they, or semi-autonomous like this, are they guided by rules that say don't
Yes.
bump into each other and don't overlap each
Yes.
other? So physically, you have coordinates where each of these creeps are, but they're sort of indistinguishable from each other in terms of their their abilities or
Yes.
their attributes.
So they have actually very rigid rules of what they do. Like they follow a really, really simple formula, like follow this path. When you see an enemy, attack him. If there is an enemy hero that attacks one of my allied heroes, then attack them. If you see him run away, follow him, even if he runs somewhere off the lane. If you don't see him again, just move back to your last point and continue. So it's really a really, really simple strategy for them. They are really stupid, one could say. Okay, so that's the combat log. Just textual information about what's happening in the game. As I said, it's just identified by name. If we have multiple objects that have the same name, we don't know which one that was. Therefore, we cannot really map damage events to objects. And furthermore, you could try, like, we see a hero attacking a creep, and we know how much health that creep has after that attack. So we could just look for a creep object that has that health at now, after the attack happened. The problem is those messages are slightly out of sync. You don't notice that when you watch the replay, because that's 1/30 of a second. How do you see if that's out of sync for 3/30 of a second even? But when you try to automatically go through that, that's a real problem. And since it's closed source, the guys who wrote the library that I'm using for parsing the replay had to reverse engineer basically all of it. And they figured out lots of things. I'm really impressed what they can do. But some things they cannot access at the moment, like the player mouse movement and the voice chat. Although, I also have to say, there is a new library in the works that can extract voice chat, but it just returns the binary data. We know which codec it uses. We don't know how to make an actual file that we can play yet. But that's something that might be available in the future if it's interesting.
So it seems like the game has only competitive aspects. Does team member, like, or the enemy, they cooperate in some way to, some sort of exchanging resources and then gaining their utility? And
so you mean like one team and the other team?
Yeah, I mean, I don't have anything and you don't have a certain thing, but I do have the thing that you need and you have the thing that I need. Then we can exchange and then we can again.
I don't think that ever happens because, yeah.
Can't I cast a spell on myself that then has an area of effect that affects my teammates so it can boost their health or stuff? So there's some actions that are explicitly.
Yes, but that's like within one team. Like across teams?
Yeah, across the team. Yeah. Like in a Prisoner's Dilemma or Color Trails game.
No,
they're
really
both cooperative and competitive aspects.
Yeah. There's really only one resource, so there would be no reason for trading.
Okay.
If I have gold and you don't, I'm keeping it.
Yeah. So there's not really. Yeah. You cannot exchange hostages or something because. Actually, so maybe something like that happens implicitly, like someone moves to enemy territory, and the enemy team could easily kill them, but they don't because then they would be ambushed. So that's kind of like that situation, but it's not willing cooperation. It's more like out of a need. Maybe. That's kind of what you mean. Yeah?
I was thinking that denials might be kind of denying a resource to the other team, but that wouldn't be cooperative.
No, that's not cooperative at all. Yes?
How many discrete events would you say there are in a typical game?
So the discrete events I extract are currently around 50,000 for a 50-minute game. There are a lot more that I cannot access at the moment. So it might be 100,000. I don't know. Yeah, so because you mentioned it, you can also attack your own creeps to prevent an enemy from killing them, so they don't get the money. Okay. So, but this is like maybe an opportunity for the instrumentation to augment the data that we can get and try to find ways to get additional data. Maybe we talked about overlaying the game with mouse capture software. Nice.
Don't touch the board.
Okay. So that was yes.
Yeah. So are there other game platforms that are open source? So I guess I haven't really heard what the incentive is for using DotA and not something.
Oh yes, thank you. That's a very good point. So the incentive for DotA is it's an episodic game. It features lots of conflict. It features players making decisions with hidden information. It features players like coming up with goals for themselves and then dropping those goals because they get new information. So it contains lots of things that we care about in research. And it has a library where we can extract lots of data. So other games that have the same kind of gameplay or same kind of information are even more closed, like League of Legends. And so we looked into DotA 1, which like the predecessor, which was mod for Warcraft 3. And you could basically mod it even further, but it had some even that had some restrictions of what you can do. So yes, that was the most open game we found that contained the information we wanted. Yes?
A question to follow up with his question. He asked how many discrete events. So I'm
Yeah.
thinking these are like instances of some action or event.
Yeah.
When you classify them, how many classes of events are we looking at roughly?
At the moment, there are like 220 classes. So there is, we actually have a text file where I have for each discrete event class that I currently extract what it does, which parameters it has, and what it means basically. And that's around 200. That comes from the fact that each hero's abilities are different. So each hero ability is a different kind of event because they have different targets, they have different effects, they have different durations and things like that.
You guys probably have a taxonomy of those classes, correct?
Yes, more or less. That's one of the things we are working on, I would say. Yeah.
If, for instance, we ignore all the variety of hero skills and instead use maybe 10 classes of hero skills, like the ones that you had on your slide, then aside from those, you would say there are maybe 15 other types of events that we record, or 20?
Maybe 20, 30. Yes, so the hero abilities are really the bulk of the abilities that there are. I think it's more like 50 because of how one models those things. So there's like an aura, which is we have a hero, and whenever someone comes in range, they get a bonus. So in our current model, whenever a hero moves into the range, that's one event, and when he moves out, that's another event. So that kind of adds up quickly to lots of different event classes, even though they are just like, maybe we could also lump them together into one superclass. Yeah. So that was how the game stores the data. Here's what we do to extract like actually readable information from that data. Currently, there's a text-based log file that just contains like user messages that happen, particle information, and things like that. I use that for actually writing the code because it's much more accessible to see what happens in each tick and how each ability is represented. But it's interesting. It might be interesting for other people to look at that to see what kind of information is available. From that log file, I create an XML file, which contains a plan-like structure where all the actions that are executed by each hero that contains all the actions that are executed by each hero. And that's what we use in the narrative processing task. I extract that using Python with the Tarasque replay parser library. I just wanted to reference them because they're really doing awesome work reverse engineering this binary format. And furthermore, there are several tools that generate graphs from these plan-like structures. So I have an example for a subpart of a graph because I will not show a 50,000 node graph here. And all this is contained in this nice directory structure. So for each replay, replays usually have numbers which are kind of like timestamps when they happen, but they're not Unix timestamps. I don't know exactly what time that is, but they are increasing over time. Then we have the dem file directly in that folder, and a parsed subfolder that contains the log and the XML file. And there's a graphs subfolder where we store the graphs that we extract, and an associated files folder where I basically place whatever else I need for intermediate steps. And that will be available on some NFS share for LAS people at some point when that gets going. So as I said before, each hero records its position information 30 times a second. So what I do is I take this position data and try to fit line segments. And I do that as follows. As long as the hero moves within 30 units of a line, where 30 units is like a really, really small distance in the game. melee range in the game is 128 units. So that's like about the radius of a character itself. As long as he does not leave those 30 units, it's considered one straight line, even if he might wander slightly from that line. If he stands still for more than a second, then his movement is concluded. So, and that gives a nice approximation of line segments for the hero's movement.
Hey, Markus. So
yes.
You're doing this analysis and creating these movements based on the labels that it's like Hero 17 or Crystal.
Yeah.
So Crystal Maiden does all this stuff. Crystal Maiden, and then each line in your log file says Crystal Maiden, or there's a label that says Crystal Maiden is doing these kinds of activities.
Yeah.
Suppose I take 50,000 observations in your 50-minute game file, and I remove all the labels. All the Crystal Maiden labels gone. All the Hero 17 labels are gone. All the creep labels are gone. Can you recreate the movement of individuals? Can you identify?
No.
Not at all.
Well, I would say maybe. In the general case, it might not work. So what can be done is, since heroes rarely ever teleport, you can say, okay, this hero, that has to be the same hero because they're close to his last position.
Okay, good.
So that can be done. But in a general case, there might be some instance where a hero teleports somewhere and then you don't know where they went.
Okay.
So, yes.
But if there are several characters in close proximity to each other,
yeah, that might fail.
You should be able to, I mean, are you able to say that this is one of these characters and here's a different entity and here's a different other character? Because they're physically close from moment to moment?
It should work, but as I said, there might be corner cases where it fails.
Okay.
So if they really move right next to each other, that might not work anymore.
You said the radius of a character is, what, 100?
Well, 128 is melee range, so that's actually slightly more than directly next to the character. So when you see someone swing his sword, the damage event can be slightly away from them. I think I'm certain that heroes can get closer than that. They might not get closer than like 30 units, so that might work. But I'm not entirely certain that there are not some corner cases where it would fail.
In a lot of cases, it would be like a cracking problem.
I was thinking escape. Period.
But yeah.
But yeah.
Okay, any more questions about movement? Okay, so abilities, sadly, ability activations are not contained in the replay file at all. But what's contained is ability objects and their cooldown. So when an ability has 0 cooldown in one tick, in the next tick it has 15 seconds cooldown, we know it was activated. So that's how I track the ability activations.
Now, I don't remember this from before, but
sure.
Are the movements and the abilities stored together, or are those separate? So does the character information also contain their position and the...
So the hero object contains a position and an array of ability objects, and the ability objects contain the cooldown.
Okay, so there's more information would have to disambiguate who the...
Yes.
Who
yeah,
the
so
hero
if they get close to each other, it's... Yeah, Crystal Maiden has a certain set of attributes, and
right.
Hero 17 has a different set of attributes.
Right.
So as they come close to each other,
yes.
you would have to disambiguate that way.
Right. Yeah. So one thing that might simplify that is that each hero has unique abilities. So it cannot happen, it usually cannot happen that some other hero casts Freezing Field, because that's Crystal Maiden's ability.
Right. So that could help your teleportation.
Yes.
Your blink problem.
Yes. Yes, usually. So one of the rules of the game is actually everything should be prefaced by usually, because they like breaking their own rules all the time.
So, sorry, they told me they had just 2 more screws to do on the floor, so maybe this is the last one.
Okay. And also, like, all the abilities are different, so how to find the targets of each ability has to be done on a case-by-case basis. And that really involves going through each ability, looking how it's represented in the replay file, and trying to figure out how you can find the targets. Damage events are taken from the combat log. As I said before, that's text-based, so it's not always possible to uniquely determine attacker and target. But where it is possible, I do that. Yes, I say that's possible, I do that. Where I can say with certainty who is the attacker and who is the target. Even if there's like a strong likelihood that the target might be this creep over that other creep, I refuse to guess. That might, some people might be interested in changing that and improving the guessing method, I don't know. Auras and modifiers. So auras are basically hero abilities that grant bonuses to other heroes. Modifiers are basically come from items that make a hero invisible or something like that, or provide them with healing over time or mana over time. They are also taken from the combat log. For heroes, it's easy because there's only one hero of each type, so that's uniquely identified, but for the creeps, the same restrictions apply. So here's an example for a log file. Basically, we have the tick at the beginning of each line, and then we say, see, Crystal Maiden activated her Crystal Nova. And in the same tick, we see she does the modifier Crystal Maiden, Crystal Nova to some creep, and Chen, which is some other hero. That means wherever she activated her Crystal Nova, as a reminder, that was that round thing that she can cast on an area. So wherever she cast that, there was one creep and one other hero. And for visualization purposes, a particle with the name Maiden Crystal Nova is created at this position. So I basically get this information from the replay file, and for the plan-like structure in the XML file, I create a plan step. And a list of these plan steps is exactly the file I was referring to earlier. So we have a list of each type of, each class of events, which is the name of the plan step, and what parameters it has and what they mean. And here we say Crystal Maiden, casting at tick 6724, her Crystal Nova at some location, and targets exactly the creep and the hero that we saw before. So for move events, that's a bit more tricky because move events are not instantaneous. So we have a start tick and an end tick, and an origin and a destination. So in this example, we see Crystal Maiden moving from somewhere in the bottom left quadrant to somewhere else in the bottom left quadrant over 100 ticks, which is like 4 seconds. And finally, that's one example for a graph that I extract. Here we have yet another hero, which is called Mirana, and someone called Smokescreen, cuts Smokescreen on her, which is an ability that makes her silenced and slow, I think. Then we see Mirana damaging Crystal Maiden, and after that we have like two heroes. Mirana keeps moving, and Crystal Maiden, actually her next event is that she gains a level by being near some creep death, I guess. And we see Mirana loses the Smokescreen debuff that she got before. So we can extract all kinds of pretty graphs like this for the whole replay, for parts of the replay, for basically any sequence that we're interested in.
And you can see how long the smoke screen as an effect lasts from the
Yes.
time at the top to the time at the bottom. So it's 100 ticks, I guess. I guess it takes 8 ticks to actually activate. So you cast it at 1 tick, and 8 ticks later it activates. Is sort of that first transition.
So no, the problem is that we don't see the cast actually, because it was cast by some other hero.
Okay.
And that would happen before here. So maybe that's an unfortunate subsection of the plan, because we don't see where the smokescreen actually comes from. But that was cast by someone else before.
And the smokescreen event can last a variable number? I mean, this looks like 100 ticks. So,
so actually, the smokescreen creates a cloud of smoke in some area on the map. And whenever an enemy hero moves into that cloud, he is affected, and when they move out, the effect ends.
Okay.
So at that point, Mirana moved into that circle. At that point, she either moved out or the cloud ended. We don't know which one it was. Yeah.
You could figure that out if it was important.
Yes, if it was important, you could figure that out, because the smoke screen has a constant duration. We know when it was activated, so yes, we could figure that out. So what I currently can extract are those 23 heroes. I won't read them off, but if you're interested, look at the slides. Damage and heal events with the restrictions I mentioned before. Some item auras, those are like the most common ones, Ring of Basileus and Mechanism. There are some others that occur in a large number of games that I'm going to implement soon, but that's just a matter of time. Hero last hits, like when a hero kills a creep, that's important because they gain money for that. When a hero levels up, when he dies, when he levels up some ability, when he buys and sells items. And at the beginning of the game, we have some setup events that tell where a hero which heroes spawn, where buildings spawn. Yes, that's basically the setup. Like everything you need so you can get the game running. And yeah, this file. Sorry.
So finish your
well,
last line. Then
I was just going to say this file is available that I've already been mentioning like 3 times or so.
So eventually, the idea is to be able to extract all the information out, and then, or as much as you can, or
yes.
about the game, and then you can set up these extract these plans and run through the games. And let's say you'll have a library of games that you can go through and say, well, I can play this game, but what happens if I graft on this game
yes.
to this plan?
Yes, that's.
And then I can start simulating games and saying, well, under this situation, this would be a way to go, and
yes.
under this situation, this would be a way
yes.
to go.
Very exactly like that. So interestingly, the creators of the game introduced a new feature like 3 weeks ago, where you could watch a replay and at some point say, stop, I want to take over the game. I want to take over the game from that point in time. And then it creates a new game where you can just invite 9 friends, and then you can start playing that game from that point in time.
Well, but once you have this, once you are able to do this, you can start saying, what happens if I go back and change this part of the game?
Yeah. Yeah, exactly.
Does create its own replay, so
yes.
that you can resume from anywhere.
Right. You know, I can change this thing right here, pretend that instead of getting this many hits, they only got this many hits.
Yeah.
So, okay, so
that's a feature.
This implies that
no, they can go in there and they can change the replay file.
Oh yeah. Well, that's what you were asking, wasn't it?
Well,
that's not so.
Not really, I don't think, because there's causal repercussions.
Yeah, but that'd be cool to see what those repercussions are.
It would be, but it's non-trivial to because you've got all these replays, just to be able to graph them together, because the states don't match at the grafting point. So, when you do the graft, there's a lot of things you're going to have to throw out from the unexecuted portion because they were dependent on their original.
There's all of a sudden like a giant blink, so you're going along one set of narratives, and you stop those and sort of graft on some other ones. Some of these may continue, but the other ones are like a blank.
But if you have the planning, when you put in the planning, you can say, which ones of these would continue, which ones wouldn't continue.
Yeah. Sort of imagine new futures.
Imagine that.
Yeah. So
it all comes together.
It's one evil plan, Bill. Come on.
We're working yesterday. Yes.
Can I ask a question here? Okay, so there's so many different directions you guys can go in, at any point. I know, your imagination is exploding, but I would imagine there's some theory, right, about games, and maybe there's some theory that's developed over time in terms of narrative games that maybe you're trying to, so when you implement things, you're maybe thinking of maybe something that may be more theoretical. Is that the case that you're trying to evaluate, or not really?
So I would say for the log files as they are now, they are pretty agnostic of any theory, because they really just take the information that's in the replay. But yeah, so one of the things we want to do is like create more abstract actions from the ones we have, and those are clearly going to be informed by some kind of theory, by some kind of intent that we have for using them.
That's your last bullet here.
Yes. So yes, one of my bullets here is future states processing, which can use this replays to like stop the game at some point, predict how it might unfold, or if it changes.
These slides beforehand.
Yeah, they were secret. They were classified. Okay, so planned improvements. So as I said, there are lots of things missing that may or may not be implemented in the near future. So we have 23 heroes available. It would be nice to have more, maybe all of them, but it's not a high priority because you can already create lots of replays with 23 heroes. And they represent all different, like they have melee heroes, they have ranged heroes, there are spellcasters, there are heroes that just want to attack. So each kind of hero that you want to play is represented somewhere. But there are others that have completely crazy abilities that might be interesting, that we might at some point investigate. Currently, a new parser library is being written by the same guys who wrote the one I'm using, and they can extract more information, for example, the voice chat, as I mentioned before. It's still in development, so it's not completely done yet. It's not usable. Well, it is usable, but it's not nice to use, so they're working on that. And what we are trying to do is like create higher level representations of these actions. Maybe there's an opportunity for data readiness level research in there. Yeah. So that was what I had. Yes?
To clarify, you cannot write, you cannot write a replay that's valid.
No, I cannot.
So I want to throw out there, we are working on a system that can visualize a replay using the plan structure. So if you were interested in changing how the game went out, you could write that as a plan structure, and there would theoretically exist a program that could visualize it as if it were a real game.
Yeah.
Yeah, but you cannot write one. And is the situation the same for all the other, for example, League of Legends? The log file is not public either?
League of Legends does not even have replay files.
Do you know ECE2, StarCraft 2?
Yes, I know StarCraft 2. I played around with the map editor at some point.
No, the replay files, are they public or not?
I don't think they are.
I mean, there are also libraries that
yes,
read them, parse them.
I have to say I don't really know.
What is the reason for the replays not to be public?
Ask Valve. I don't know. So
it's free, right?
Yes, it's free. But one thing I have to say is I'm talking to the developers of the library a lot because they are really awesome at giving support and stuff. And they said, yeah, they had some questions about the internals of the replay, and they asked Valve, and they actually replied. So it's not officially supported, but some of the developers are willing to give support. That's how they figured out, I don't know what. I think the combat log was stored in some crazy format, and then they asked, and it's like, yeah, it's quite easy because we had to, I don't know, store it efficiently in some way, and yeah.
Do you know by any chance the networking protocols used is TCP, UDP?
I don't know. So the thing is, the data that goes over the network is quite different from the replay data.
Oh, it is?
Yes. There was someone who was trying to write a live parser for the network data. I haven't heard from that project in a couple of months. I don't know if he gave up, I don't know. I think it was for some website, so he could not share all the information he had because it was proprietary work. But he tried doing that.
So you're certain that the replay is downloaded post-game from the server?
Yes.
And you as a player, you don't have the replay, you just have a version of a replay So in StarCraft there is no such thing. It's at the end of the game you have the replay because you have all the information that was on that server.
Yeah.
So there is no need to download anything.
Yeah, so in the case of DotA, the server records the replay. But there is a way to run a server locally if you are in a local network, and then the replay will actually already be stored on your machine.
Of course.
Yeah.
But conceivably, you need to have all the information in the replay to see the game, right? To actually play the game.
No, the other way around. The replay, you need...
Well, you may need only a subset, right?
Yes, you only need a subset.
Only what's around to you, maybe. You don't need to know what's happening in the other corner.
So
if clips hit each other.
Yes, but the server, to actually enforce the game rules, the server needs to know a lot more than you do when you just watch the game afterwards. So the replay does not contain all that information that the server would need to enforce the game rules. And when they introduced that mode where you could take over a replay, they actually had to change the replay format because they had to include more information so you could actually take over from some point.
Any other questions? It's 2 o'clock for Markus.
Yeah, I have a question actually.
Sure.
How easy and how hard for you to change this recording process? For example, if I want to only record the movement, or if I found some other information that are of interest, I want to add that into state log.
So I would say it's quite easy because it's... So I tried to make it as easy as possible to extract only information that you actually want. It's code, so it's my code. I would not say it's like the easiest to change, but I tried to make it like modular in the sense that if I want to add more information, you can add some more observers to the data. If you want less information, then you can remove the observers that I have. There's There's some hacking going on due to the way the replay is stored, so that might be tricky to change.
Yeah, but for example, if you want to change the limiting parameters, for example, how you calculated the distance, you said there's a parameter, and then if you want to change that parameter, then you would have to decide when you record the distance. For example, you say 1 second, then you consider it stopped the moment.
Yeah.
But if I change that limiting factor to 10 seconds, would that be flexible from the programming's perspective?
Yes, that's very flexible.
So, but when you calculate two objects when they're so close, and then is there a limit that is so close you can't tell them when they parse?
So what I do, so that was, I think that has to do with the question you asked. What I do, I actually know exactly which character is where.
Yeah, but
if you remove that labels, anything might happen. I don't know.
All right, so I just want to say, because we didn't have cookies, I've got something for Markus here. fresh from
thank you,
Port City, whatever it is over there. Let's thank Markus for his time. And like I said, we're going to have at least one more of these special off-cut IDSS presentations in a couple of weeks where we talk about some instrumentation things and some interesting national processing approaches. If you go through Markus's slides here, there'll be these little phrases that show up that are in boldface: future-space processing, cognitive processing, these sorts of things, data readiness level, and they're coupled directly to sort of the research themes that we talk about at the LAS that you can see on this website, las-ncsu.org, for more information on those kinds of things we're doing. So thank you for your time.